as a process that has to be done prior to data processing and analysis. Now, look at this next slide, which are some slices of carrot cake. Wow, aren't these delicious? And this cake did not come out just like this. The ingredients originally may have looked like this and had to be prepared for the actual baking process. You see some of the ingredients here, the eggs, the flour, and so on. And as they cannot be used to bake the cake. They have to be prepared. Egg has to be beaten, separated from the shells. Flour has to be sifted, and so on. Likewise, the data that will have to be used for your study or research have to be prepared for them to be processed and analyzed. Data are the inputs that will be the basis for results and discussion. And finally, conclusion and recommendations for your research. The subsequent discussions and decisions can be accurate only if the data are also accurate. Now, data preparation is the process of gathering, combining, structuring, and organizing data so they can be analyzed to come up with accurate and relevant conclusion and recommendations. The steps in data preparation vary from author to author, but basically, they involve the following. First, data gathering or collection, then data checking, data cleansing, data structuring, data transformation, and data validation. In data gathering or collection, this is where you gather information using the approved method and tools which you presented to your panel during the research proposal time. So your method could be through a survey, an experiment, or any other method. And the tools would depend on the method you have selected and was eventually approved. Now, in data checking, you check for readability of the data, the accuracy, and completeness. And this has to be done right away. Imagine that you're holding that sheet of paper that has the list of data that were gathered just a few minutes ago, and you look at that list and maybe there are columns that remain blank, and there's still time to go back and correct the information gathered or to ensure that you have complete information. If you're back at the office or your workplace or your study table and the experiment is already done, you would no longer have the time. That would be the danger there, to go back and correct or get the information that is still lacking. So in data cleansing, once the errors, the incomplete, incorrect, duplicated, or irrelevant data have been identified, the step to take is to fix or remove them from your data set. Then in data structuring, this involves organizing the data for you to be able to use them efficiently. There are many ways of structuring your data depending on the complexity of your data and the objectives that you would like to achieve. But here's a simple one. Let's just say that we have water effluent sampling from various sources. So you list the location, the date sample, temperature, and so on. So you see that the data at the left, columns A, B, and C are what we may consider as your dimensions, while D, E, and F are your measures. So D, E, and F would be data that for which we would be looking for, say, the mean or the average, standard deviation, and many other computations. So you may want to filter data or use pivot table, and this would be a very user-friendly way of structuring your data. As you may have noticed, we do not have any blank row. We started right away with A1 and just started filling in the information to facilitate the use of the data when we get to the processing part. Then we have data transformation, which involves changing your data into another form that is most useful for data analysis. For example, transforming manufacturing dates to product aids. So your data, which includes some dates, may have to be transformed to a form that is most useful for you, in this case, product age. Now, when you go back, for example, to the previous slide, you can see the date sampled, and when you like to see how long ago this was done, you can transform this by having a column, number of days elapsed, or whatever information you might need for your own analysis. So now, like in the baking of a cake, you would need to confirm or check whether the cake is indeed done. And the usual practice is to just pierce the cake with a toothpick. And if it comes out clean, then the cake is done. So that's how you check for the cake being done. And in terms of data, you need to have data validation. So this involves finally checking your data before you process them. And this can be achieved by having several checks. So you will see that the things that we have discussed, all of them were directed to ensuring that our data are accurate, that they are complete, that they are relevant, and that all the wrong or inaccurate and irrelevant data are weeded out. So for the final check, you'd like to make sure that the data type is correct. For example, for a field that requires numeric data, that non-numeric data will not be accepted by this field. So in the spirit of ensuring that that does not happen, there might be a control that can be put into that column such that only numeric data would be accepted. Then next is the format check, where for a field that requires complete date, for example, the format can be this way. You have for month, DD for day, and year. Of course, you can also include a control there for the months, such that only months 1 to 12 would be accepted. If a wrong month, like say 13, is encoded, it would be rejected during encoding. Then consistency check. This is to ensure that the data are logical. For example, the expiry date of a product should be later than the manufacturing date. So you can just run through the list and even make a simple formula showing the difference between dates to ensure that the expiry comes after the manufacturing date. Then the range check. So there are data that are expected to fall within a certain range, like months, as we discussed a while ago. So months, the acceptable numbers for months would just be 1 to 12. And if you see, for example, that you have a month which is 13 in your range check, that would of course be rejected. Then in code check, the universal product code, for example, is numeric characters only, and any non-numeric character in that column for universal product code, that's just an example, should not be accepted. Then in the uniqueness check, a check can be made for unique data like email address, and if the email bounces back, then the email address is not valid. Now we end this topic and data preparation with this verse: trust in the Lord with all your heart and lean not on your own understanding. In all your ways acknowledge him, and he shall direct your